Hello and welcome back to this channel where we talk about chemistry. Alright, for this video I'll be talking about hydrogen and its structure. First of all, hydrogen is a chemical element that happens to be the first element on the periodic table. Hydrogen is a non-metal. It is also a gas. It has the atomic number of 1, which is equivalent to the number of protons in the nucleus. It has one electron that is orbiting around the nucleus and is very important in industrial production of many other chemicals. Let's go into details about hydrogen. It was discovered in 1766 by Henry Cavendish. What are the features he observed? He observed that the gas was highly flammable, that is, it catches fire easily when exposed to naked flame, and that the gas also burns in air to produce water. That is where the name hydrogen was coming from, and the meaning of the word hydrogen is water former. Alright, where can we find hydrogen? In nature, hydrogen makes up approximately 1% of the Earth's crust, but in its abundant form, it is about 75% of its mass. Hydrogen can also be found in some celestial bodies such as the sun and the rest. Okay, in free form or in free state, hydrogen does not exist compared to oxygen that is freely in the air. So hydrogen does not exist freely, but it exists also in combined form, such as um, in water you can see hydrogen, in acid you can see hydrogen, in organic compounds and fossil fuel. Let me come back to acid and organic compounds. For acid, or for all acids, the first element in the structure or in the chemical formula of any acid is always hydrogen. So in most of inorganic acids, the first element is always hydrogen. But in organic acids, we identify organic acids having COOH as an indicator. In that format, there is hydrogen in all organic acids because of the last hydrogen atom that is in the structure. All right. Atomic structure of hydrogen. The atom of hydrogen comprises of one electron, and for an atom to be neutral, the number of protons must equal to the number of electrons, and atomic number is the number of protons. That means an atom of hydrogen have one atomic number, which is the same thing as this number of electrons. Okay, so atomic mass, that is 1.008 units, and the electronic configuration or the electron configuration of hydrogen is 1s1. So one proton in the nucleus and one electron orbiting around the nucleus. Note, owing to the structure, the way the atom of an atom of hydrogen look like, there is only one electron in its shell, and therefore there is need for one other electron in that structure to make it complete according to the formula 2n square, to make it duplex or octet structure complete. For this reason, hydrogen resembles helium atom in its molecular state. Where can we put hydrogen? The position of hydrogen in the periodic table. Where can we put hydrogen in the periodic table? Okay, hydrogen is placed in group 1, that is alkali metals. So when you check your periodic table, on top of the first group, that is group 1A, hydrogen is always placed there and shows similarity with group 7 or 17 element. I am saying group 7 or 17. The method of numbering the groups, either from 1 to 18 or from 1 to 8 or 0, you are still correct. So it's either you say group 7 or you say group 17. I mean halogen group. So elements in group 7, they are called halogen group. Elements in group 17, they are the same thing as halogen group. All right. So what's the condition for placing hydrogen in group 1? The condition is that it carries one electron on the only shell, and all elements in group 1 have one electron on the last shell, including hydrogen. All right. Now, when you come to the condition for placing hydrogen in group 7, all group 7 elements, for them to become a molecule, they need one, or for them to have a complete shell structure, they need one electron for the last shell to be complete. So the same features that the group 7 or group 17 elements, that is the halogens, are exhibiting, the same feature is what hydrogen is also showing. That means normally hydrogen can be put in group 1 due to the existence of only one electron on the last shell, and it can also be placed in group 7 due to deficiency in electron on the last shell. That is, it needs one more electron to have a complete shell structure. Hydrogen is in period 1. Why? Because it have only one electron shell. There are two things that we use to place elements in group or period on the periodic table. The first thing is the number of valence electron. The second one is the number of electronic shell. So hydrogen has only one electronic shell, so it is placed in period 1. It is placed in period 1. Excuse me. Remember that hydrogen can be placed. Okay, that is what I have said earlier. So that is the last part of the screen. Let's proceed, please. So oxidation number of hydrogen. What is the oxidation number of hydrogen? In common compounds of hydrogen, the oxidation number is +1, but in hydrides, the oxidation number is -1. So that means hydrogen has two oxidation number, +1 and -1. +1 and -1. Properties of hydrogen. Physical property. Hydrogen is colorless, it is also odorless, and it has no taste. So it is colorless gas, odorless gas, and tasteless gas. All right. Hydrogen is the lightest element ever known, highly combustible, that is, can catch fire easily. So The boiling point of hydrogen is minus 253, approximately minus 253, and it melts at minus 259.16 degrees Celsius. It is neutral to moist litmus paper. That means hydrogen is a neutral gas. It is relatively insoluble in water. That does not mean that it cannot dissolve in water at all, but relatively compared to oxygen. Oxygen dissolves in water, you know. So hydrogen is relatively insoluble in water, but very little amount of hydrogen dissolves in water. Chemical properties. The chemical properties of hydrogen extracted from the documents here and there, different textbooks online has been gathered together for you here. So let's look at the first part, the unique nature. Hydrogen has a single valence electron, similar to group 1 alkali metals, but exhibit non-metallic properties like group 7. Please don't forget. So hydrogen resembles halogens when it comes to chemical property. Okay, it is a non-metal, it is not a metal, but it only fits into the metallic group 1 when we observe that it has only one electron on the last shell. It is usually placed in group 1 for conveniency, or between group 1 and 7 to reflect its unusual characteristics of accepting an electron to become H2. Tendency for stable configuration. Hydrogen tends to achieve the stable electronic configuration of helium, that is duplex structure. It does this by the following process. 1. Forming a negative hydride ion by accepting an electron from another atom. All halogens are negatively charged ions. All halogens, they form negatively charged ions by accepting electron. The same thing is applicable to hydrogen. When it accepts electron, it becomes negatively charged ion. All right, covalent bond formation. So hydrogen can share its lone electron to form H2 molecule. All right, so formation of positive hydrogen ion. So when hydrogen form positive ion, that means it has donated the only one electron and forming coordinate bond with molecules having lone pairs of electrons. Example we have in ozonium ion with water and ammonium ion. So another one is combination reaction. Hydrogen reacts with metals. Hydrogen reacts with metals to form hydride. That is the best example there. That is, the best metal we can use here is sodium metal reacting with hydrogen to form sodium hydride. Hydrogen also reacts with oxygen. That is, it bonds with a pale blue or invisible blue. So we've talked about hydrogen flame in our previous video. You can check that in the other video. So where we said hydrogen flame is it generates very high energy, but the flame is somehow invisible because it does not burn the yellow region. The yellow region is not, it does not even show yellow at all. At times the hydrogen flame is invisible. So it burns with a pale blue flame to produce water vapor. So if you see that chemical equation, you see hydrogen gas combined with oxygen gas to give water. And beside that water, you see G there. That means it is gas, gaseous water, which is the same thing as water vapor. With halogens, hydrogen also combine with halogens to form halides. For example, we have an example of halide here, that is hydrogen chloride. So we can also have hydrogen um, bromide, and so on and so forth. The reaction with chlorine is spontaneous, that is, it occurs on its own without influence in bright sunlight, but very slower in diffuse light. So when we say it is a reaction is spontaneous, that means it occurs on its own without external influence. In this case, this is photolysis reaction, a reaction that involves light. All right. Reducing action of hydrogen. Hydrogen is a strong reducing agent. It reduces metal oxides like copper 2 oxide, lead oxide, iron oxide, and zinc oxide to their respective metals, while being oxidized to water. This is applicable to those metals that are both hydrogen in the activity series. In the activity series, there are some metals, active metals, that are both hydrogen, and those metals can only, the oxides of those metals can react in this manner, and it will reduce the metal to metal, the original metal, and the hydrogen itself will become oxidized to water vapor. How do we prepare hydrogen? Preparation of hydrogen can occur both in the lab and in the industry. So in the lab, it is just for us to test, to confirm, is it possible? And industrial production is the production that occur in large quantity, all right? Let's see some laboratory preparation methods. The first one is action of dilute acid on reactive metals. Like I said before, metals above hydrogen in the activity series react with dilute metal acids, or mineral acids, I'm sorry. For example, we have sulfuric acid and hydrochloric acid to liberate hydrogen gas. Example of such reactions are shown in the chemical equations below. The first example, zinc and dilute sulfuric acid, and the second one, calcium and hydrochloric acid. In this case, hydrogen is generated in the two examples. Let's check this out. Look at it vividly. You will observe that in the tissue funnel was what is called dilute acid. Then there is zinc pieces inside uh, the flask. In that way, the gas will be generated through the delivery tube, and here the gas is collected over water. Therefore, this gas, hydrogen, that it is collected this way, it needs to be dried. This method of collection of gas is called downward displacement of air, or upward delivery. So this image is the simplest image that describes production of hydrogen in the lab. Number two, action of cold water on reactive metals. Reactive metals like potassium, sodium, magnesium, calcium, they can liberate hydrogen from, let me say, cold water. So in this format, you have calcium reacting with water, to form calcium hydroxide, and hydrogen is produced at the same time. Same thing is applicable here. Look at this image. Okay, look at this image. At the top, the gas we are expecting here is hydrogen. We have the beaker, we have the filter funnel, and we have the calcium in the funnel being covered by the funnel. And at the tip end of the funnel, it was closed for us to trap the hydrogen gas. All right. Number three, action of steam, that is hot water on metal. As in, steam is that gaseous water, steam, gaseous water coming out of the boiling water. Steam reacts with hot metals like iron, magnesium, aluminum, and zinc to liberate hydrogen gas. The example here is very clear. All right. Action of alkalis on metals. Alkalis on metals. What are alkalis? What are alkalis? Soluble oxides. Oxides that are soluble in water are alkalis. Certain metals, for example, zinc, aluminum, tin, lead, react with hot solution of alkalis. For example, sodium hydroxide or potassium hydroxide to produce hydrogen gas and the corresponding salt. So in this process, salt will be produced. In case anybody asks you to describe production of any salt, you can as well use this part of the notes to explain by saying salts are generated or formed when a particular alkali out of the two, sodium hydroxide or potassium hydroxide, reacts with certain metals such as zinc, aluminum, and you name the salt. So in this case now, we are looking for hydrogen. In the first example, the hydrogen gas was produced and the salt formed was the Na2ZNO2. All right. If you look at the second example too, that is the use of calcium hydride and water. All right. So industrial preparation, hydrogen gas is produced in a large scale for industrial use using several methods. Number one, we can generate hydrogen from hydrocarbons or natural gas. We can also generate hydrogen from water gas, that is Bosch process. We can also produce hydrogen by electrolysis process and from cracking of petroleum products. Let's check this from production of hydrogen from hydrocarbon. We have methane, CH4, is the main constituent of natural gas. It reacts with steam, hot water, the vapor coming from boiling water over nickel. Nickel is the catalyst, and the temperature for this should be 800 degrees Celsius, and the atmospheric pressure should be 30 atmosphere. So in this case, just be mindful of what you are getting. You are getting carbon monoxide or carbon 2 oxide and 3 moles of hydrogen gas using steam or hot water or vapor, water vapor, and what we call the raw material, methane. Okay, more steam is passed to convert carbon monoxide to carbon 4 oxide. In that case, more hydrogen will be generated again. Carbon 4 oxide is removed by passing the mixture through potassium hydroxide solution, leaving the dry. So in this case now, potassium hydroxide is a kind of remover of carbon 4 oxide. So from water gas, this process of producing hydrogen from water gas is called Bosch process. Water gas is produced by passing steam over white hot coke. Coke, in this case, is an example of carbon. Is an example of carbon Coke in this case is an example of carbon. All right. Coke is an example of carbon. So you can see the equation starts with C, carbon, plus water vapor. So what you have is CO, that is carbon 2 oxide or carbon monoxide, and hydrogen gas. The two of them, the combination of the two of them is what is called water gas. Okay. More steam is passed to produce carbon 2 oxide, and hydrogen gas will be generated. So the first step is to produce the water gas. Then you use the water gas by adding more steam. Then hydrogen gas will now be produced. It is a two-step production. All right. The next method is by electrolysis. So hydrogen gas is obtained as a byproduct at the cathode during electrolysis of sodium chloride. So when you are doing electrolysis of sodium chloride, the byproduct that will follow it is the hydrogen gas. Okay, it's the hydrogen gas. The process is called electrolysis of acidulated water. Please don't forget that. Acidulated water. Hydrogen and activity series. Hydrogen is placed in the activity series. Let me say what activity series is: the arrangement of metals, arrangement of elements, metals, metallic atoms in the increasing, okay, from top down will be decreasing order of reactivity, but from bottom up it will be increasing. So the most active should be potassium, followed by sodium. Popular scientists can make a zoo in a low humid country more satisfactory, plenty, good. Of course, you know, gold is the last one. Gold, plenty, platinum. So those ones are least very, very weak active. They are not that active like sodium, potassium, magnesium, calcium. So it is less reactive than alkali and alkaline earth metals. That is hydrogen is less reactive than group 1 and 2 metals. In that order, hydrogen can displace less reactive metals like copper from their oxides. All right. From cracking of petroleum products, hydrogen is obtained also. This should be the last part of the other slide. So hydrogen is obtained also by as a byproduct during the electrolytic cracking of petroleum products. I think we have mentioned this before. So let's talk about isotopes of hydrogen. Very importantly, do you remember the definition of isotope? What is isotope? Isotopy is the phenomena. So how do you define it? A situation whereby a particular atom have the same atomic number, but what? Different mass number. So there are three isotopic forms of hydrogen. The first one is protium, most abundant. It has one proton and it has no neutron. Okay. Deuterium, or look at the symbol. Look at the symbol. Majorly, we use capital letter D for deuterium. It has one proton and one neutron. Then tritium has one proton and two neutrons. It is tritium that is radioactive in nature. How do we test for hydrogen? How do we confirm that a particular gas in a container is hydrogen? So when you put a lighted splint, a burning splint Like some of you may not understand what a burning splint is. Let me explain. When you strike a matches, when you strike a match, it will bring out a flame. When you put off the flame, the stick still glow with that yellow color. So that thing is called burning splints. When you introduce into a gas container, it burns immediately with a pop sound, confirming the presence of hydrogen in the container. So that is just the only test available for hydrogen gas. When you put a burning splint into a container, a gas jar that contains hydrogen, it produces a pop, a pop, pop sound. Use of hydrogen. Generally, we have production of ammonia, that is Haber process. So another one, hydrogenation of oil to make margarine, Use as fuel in fuel cells and rockets. Okay, hydrogen is also used in welding, that is oxy-hydrogen torches. We also use hydrogen to reduce metal oxides, to extract metals. Okay, let's talk about the specific uses of hydrogen now. The 10 use of hydrogen are stated in many documents everywhere online, is what I have gathered here. 1, in filling weather balloon, because it is the most lightest gas and it has very low density. It's not heavy. That's the meaning. So it's very light. Number 2, in the production of ammonia by Haber process. Number 3, in oxy-hydrogen flame used in cutting preheated metals, because the mixture has a very high heating value. Like I said before, the flame of hydrogen produces very high energy. It's very hot. The temperature is very, very hot compared to the flame of candle or candle flame. So they are different. Look at the temperature range here, 2500 degrees Celsius. The reaction is highly exothermic. Number 4, hydrogen is used in converting coal into crude oil. Number 5, in hardening of vegetable oil to attain margarine, like I said before. Number 6, hydrogen is used in manufacture of plastics. Okay, hydrogen is also used as a reducing agent in the production of metals such as copper. We have said this in the chemical properties. So it reduces copper to its original form from its compounds, and lead also from their oxides. In the manufacture of methanol, so hydrogen can also be used as raw material to produce alcohol, methanol for example. So, or methylated spirit, let me use that word. So, number 9, in the synthesis of hydrochloric acid, of course, in hydrochloric acid, HCl, hydrogen is present, so it is needed in the production of hydrochloric acid. Number 10, in the production of water gas and coal gas. Water gas and coal gas, they are mixtures used as industrial fuel. Hydrides. What are hydrides? Hydrides are binary compounds of hydrogen with another element. Example of hydrides are sodium hydride, calcium hydride, even CH4 is an example of hydride of carbon, but we call it methane. Okay, covalent hydride. For example, we have CH4, NH3. Those are examples of non-metallic hydrides. Number 3, metallic hydrides. We also have, these ones are formed with transition metals. Example, titanium hydride, sorry. So those are the examples of hydride. So for hydrogen and its compounds, that is the little far we can go. Thank you very much for listening.